ladies and gentlemen. This is Mr. Green, and this is another in the series of lessons about geometry, and I wanted to go over a couple things. First of all, you should have completed everything in Unit 1 and be starting to work on Unit 2. And don't forget, anytime you make a low grade in geometry, you can make quiz corrections. I want you to look at your grade book. If you've got a low grade in a quiz or on the unit exam, please go out there, make corrections to it, submit it to the corrections drop box. I will grade it. It will get you a few extra points, and it will help your grade overall, okay? Remember, after things have been due, the next Monday I put zeros in. 28 days later, that zero gets locked in. So you need to make certain you get things made up before the end of that 28th day so that you get things done and you don't get zeros in your grade book. Okay? We're going to be looking at prisms to begin with. Unit 2, what we're going to do is we're going to go through several different types of shapes, three-dimensional shapes, and we're going to look at how to calculate the surface area and volume of every one of them. So I'm going to start with prisms, and I want to make certain I identify certain things about the prisms, okay? First of all, this is a base. What is a base? It is one of the sides of a prism that is the same on both ends. So these would be called the bases in this situation. And I'm just picking two sides of it. In this case, I'm picking the top and the bottom. Okay? This would be called a lateral edge. A lateral edge. Lateral meaning going up and down, meaning the difference between the bases. That's the lateral edges. Okay? These would be called lateral faces. Faces. And this would be called the height. Okay? So you're looking at several different terms there. You need to learn what they mean. They're spelled out a little bit easier over here, but it doesn't move over, so I had to write them in there for you, okay? So, when you're looking at a surface area, the surface area of a prism can be found with this general formula. The surface area is equal to the lateral surface area plus 2 times the bases. Why am I saying that? Well, because that's the amount of space that it's taking up all the way around and on the top and on the bottom. That's the area. Now, one thing you could do is slice it open with a net and find the area of the net. But in this case, we've got an easy way of doing this. I'm going to modify this lateral surface area just a little bit down here and tell you that there's an easy way of doing it. You find the perimeter of one of the bases, and you use the height times the perimeter for that lateral surface area. So I want you to look at this formula. Couple things in here. P, perimeter. B, area of the base. H, that's the height. Those are the terms you need to make certain you understand, okay? Because that is the general formula for a surface area. It's the height times the perimeter plus 2 times the base. Okay? So, what kind of prisms does this work with? Well, it works with rectangular prisms. It works with triangular prisms. It works with square prisms. Another word for a square prism is a cube. It works with, let's see here, pentagonal prisms. It works with hexagonal prisms. You get the idea? All sorts of different types of prisms. All of these, a rectangular prism, a triangular prism, a square prism, a pentagonal prism, hexagonal prism, a trapezoidal prism. All of these, let's see here, a rhombus prism. I'm not even going to try to spell that one. Any of these, it's telling you what the shape is on the base. So if we said it's a pentagonal prism, it's got a pentagon on the base. If I said it's a triangular prism, it's got a triangle on the base. If it's a rectangular prism, it's got a rectangle on the base. Those are the way you know what the base looks like. That tells you what area formula to use, right? Because we have different formulas for different ones there. So let me show you a problem. This is a rectangular prism. We've got a rectangle on the bottom. It's a 6 by 4. So the way I would find the area of this, I would take 4 times 6 times 2. Why? Because that's the area of the base times 2, right? And that's going to give me 8 times 6, that's 48. And I'm going to add to that the perimeter of the base, which is 20 times the height, 2. That's going to give me a 40. So I'm going to add 40 and 48, and I'm going to get 88 centimeters squared. That would be the area of this rectangular prism. Now I wrote it up there trying to avoid what they already had. Okay, they found the perimeter, 20. That's what I had here. They've multiplied the base times the length times the width and got the base, area of the base, 24. And then they multiplied 24 times 2 and got 48. The perimeter times the height, which was 40, added those together, 88. Okay, that didn't seem that difficult now, does it? Let's do another one here. Okay, this one is a surface area of a regular prism, they called it. Well, it's a rectangle on the bottom, and so to find the area, I'm going to do 5 times 12, that's 60. To find the perimeter, it's 24 and 10, that's 34. So let's see what they do first. They find the perimeter to begin with, it's 34. I'm going to multiply 34 times 17 eventually. Area of the base, 5 times 12, that's 60. So putting the whole formula together, I'm going to take the perimeter, 34, times 17, plus 2 times 60. And that's going to give me this whole number of 698 centimeters squared. Let's work one more example here. Does it work with triangles? Sure. What's my perimeter of my triangle down here? Well, we know it's a 6, 8. We have to find this third side because we don't know what this third side is. They're telling me it's a right triangular prism. Right angle means that it can use the Pythagorean theorem. 6 squared, 36. 8 squared, 64. That's 100. That'd be a 10. So I can now find the perimeter. 8 plus 6 is 14, plus 10 would be 24. Cool. Now let's find the area of that. 6 times 8 is 48. You take half of that, it's 24. So my area is also 24. Now I'm going to take 2 times that area. I'm going to take 24 times 14. And I would wind up with 384. Now remember, what is surface area? If I wanted to paint this triangular prism, the surface area would be how much paint I would need to cover all the sides. Okay? That's what you're looking at. You're looking at how much does it take to cover it all up. That's how much area is spent on the outside. Whereas volume is how much space is on the inside. We're going to calculate volume in a similar way. We're going to take this same B, that same capital letter B there, right? That stands for area of the base. And we're going to multiply it times the height. Area of the base times height. Now, area has a unit squared. Height is units, so when I take squared times units, I'm going to get units cubed. So volume is always expressed in units cubed, not units squared. Okay? So here we've got this same rectangular prism we had before. 4 times 6 is 24, times 2 would be 48. We'd be looking at 48 centimeters cubed. That's how we find the volume of that prism. Okay? You look at this one, it's a trapezoid. Well, if you just look at the trapezoidal end, we got one base that's 3 and one base that's 5. Where'd that 5 come from? Right over here. My height would be this side over here, which is 3. Right there. Told me that one. So I can take 3 plus 5, that's 8. 8 times 3 is 24, divided by 2 is 12. So the area of my base is 12. I'm going to multiply that times 7, and I'm going to get 94. Or 74 and 14, that'd be 84. 84 centimeters cubed. Okay? These formulas work for any type of shape. Here we've got a regular prism. And how many sides does it have? 1, 2, 3, 4, 5. It's 6 sides. Now we got to use that 6 to help us calculate the area of the hexagon, don't we? Because remember our formula for area of a hexagon? You remember that one? It is the perimeter times the apothem divided by 2, or 1/2. So in this case, my perimeter is 6 times 2 is 12. 12 times, or 12 divided by 2 is 6 times 1.1 would be 6.6. So I can find the area of the base is 6.6. See how I did that quickly? I hope you do. So now all I got to do is multiply that 6.6 times 3, and it gives me 13.2. Why'd they multiply times 2? You know what? That's wrong. I'm going to correct that. It's supposed to be a 3. Why? Because that's the height of the prism right there. And 6 times 3 would be 19.8. 19.8 is 19.8 centimeters cubed. Cool? So we've done surface area and we've done volume of prisms. There's one more concept I want to get across to you, and that's Cavaliere's principle. Cavaliere's principle says if two solids have equal heights, the cross sections formed by every plane are parallel to the bases. Both solids have equal areas. Then these solids have equal volumes. Where in the world did this come from? Well, in case you don't recognize it, Cavaliere is an Italian name. Mr. Cavaliere used to own a restaurant, and his son, the man who came up with this principle, noticed that if they took wine bottles and melted them, exposed them to heat, they could bend the wine bottles into weird shapes. Okay? And it was just interesting to have these weird shaped wine bottles. But they knew that if these wine bottles started off with a certain amount of liquid in them, they would still have the same amount of liquid in them. And they just compared them to the wine bottles that were the same height, same area, and they did. It's just one of those little principles that they discovered while eating. Go figure. But the whole point is, if I've got a triangular trapezoid leaning off to the side some way, and I really can't calculate the volume of it real easily, if I can find the area of the triangle, one triangle in it, one cross section, and then come over to another one with the same area, as long as I'm looking at the same heights, I'm looking at the same volumes. It works out really, really nicely. And they don't even have to be the same type of shapes. They can be completely different shapes. Okay? That way, you've got something leaning off to the side. You can find the area of one cross section of it. You can actually imagine it like a prism and just calculate the volume of the prism and not have to worry about what shape it is actually in. That's the trick that's being explained to you here with Cavaliere's principle. Okay? So I appreciate the fact that you guys are sending me the fact that you're in geometry when you send me KMLs. You're sending me that and the section number. It really helps me find some information for you quickly. I look forward to talking to you next time.